So if you're having trouble choosing the U, I'm going to go through and give you a few hints. These hints, let me start off with, are not going to work for every single problem. Okay, as I was saying in class, you are definitely going to have those moments where you choose the wrong U. You're going to choose something for U, you're going to find the derivative, and then you're going to start plugging in and it's not going to work. And at that point, you just need to say, okay, I made a mistake, erase, start over, choose something else for U. I can tell you that in general, not every single time, that U is going to be something that's on the bottom of a fraction. In general, not every time, something on the bottom of the fraction. And also frequently, it's in the power of an exponential. Okay, and that should help you. Now, the other thing to remember too is think about how substitution was defined. It was defined saying that if you have a function u inside another function like that, right? If it looks something like that, so think about how substitution was defined. It said that if you have a function inside another one and it's being multiplied by the derivative of that inside function, that meant that it most likely used the chain rule to find the derivative. Okay, so your g, whatever g is also going to have its derivative. So when you're looking at the integral, look to see what function also has its derivative in the integral. And that can also help you as well in the integral. So I'm going to show you a few examples. So let's say you have the integral of 2x e to the x squared dx. And let's say you decide, okay, u is going to be, well, now look at what you have. So you have the 2x, you have e to the x squared, but think ahead. Okay, the e to the x squared, to find the derivative of that, it's e to the u times u prime, right? So you're going to have a lot of extra things that you can't substitute into the integral. Where if you choose u to be x squared, then when you take the derivative, you have 2x. Okay, now remember the 2 is just a coefficient. It's going along for the ride. And then you have the 2x even here. So you have that 2x dx, that whole thing is du. And then the x squared is your u. So now you can rewrite the integral as e to the u du. Okay, so let's try another one. So let's try one with trig, because I know that could be a little bit more difficult for people. So we'll do tan of x secant to the 4th of x. So the first thing I'm going to look at is, where do I see a derivative of one of the trig functions? Well, there's 4 factors of secant there, which means that I do have a secant squared. Secant squared is the derivative of tangent. Okay, hopefully we know that by now. But then that's going to leave. So if we choose secant, if we choose tangent as the derivative, though, my du is going to be secant squared of x, but then I'm still left with an extra secant squared of x. So I'm not taking care of everything inside my integral. So now I'm going to look for something else for u. So let's think about splitting this up. So I'm going to write this as tan of x times secant x to the fourth, which then can become tan times secant, which is a derivative, times secant cubed. Now if I take my u to be the secant of x, my du is secant tangent, and I have taken care of this because that's now my du and the dx, and the secant cubed of x becomes u cubed. So all I have is the integral of u cubed du. Okay, let's try one more. So let's say you have the integral of the natural log of x over x. Okay. So this is one to really think about because I did just give you guys the general idea that a lot of the times when you have a fraction that u is going to be what's on the bottom. Okay, so if you make u x though, your du is just going to be 1 times dx. You're going to have this natural log of x still left over, right? And the entire integral needs to be in terms of u, so that's not right. So this is one instance where it's not going to be the bottom, okay? But remember, think about the functions that you have there and their derivatives. So I remember that the natural log of x has a derivative of 1 over x. So the function and its derivative are both in the integral. So I take u to be the natural log of x. Du, the derivative of the natural log of x, is 1 over x. So du is 1 over x dx. And now I have du and u. Done. Okay. I hope this was helpful.